mathematics. So today we will be solving one question which is they are given to us some dimensions and we need to find the weight of that particular body. Okay, so it's a solid body, right? It's given that we need to find the weight of a lead pipe. So first of all we need to understand that there is a pipe given to us. Okay, there is a pipe. So for any pipe, right, let's say this is the pipe as given to you. It will be looking like a circle from the top, which is the cross section, and this is the pipe, right? Now it's given that it's 3.5 meter long. So the length of this pipe is given to you as 3.5 meter, right? So the length is given to you as 3.5 meter. Okay, now if the external diameter of the pipe is 2.4 centimeter, right, that means the external diameter, that means let's say if it's given that the external diameter is 2.4 centimeter, external dia is equal to 2.4 centimeter, right? That means the radius will be half of that. So let's say it is R, capital R, which is external, mind it, external radius. Then the value of this R will be equal to 2.4 by 2. So this is equal to 1.2 centimeter. And mind it, this is external radius, right? This is the external radius. Now what we will do, this is the external radius 1.2 centimeter. Now the second part is given that thickness of the lead is 2 mm. That means this is made of some metal and that metal is lead. Okay, let's say this is the thickness. So if you have seen a pipe anytime in your life, then you can see from the top it is looking like this, and this will be the thickness of this pipe, right? This will be the thickness of this pipe, and this will be the entire material which will be used to manufacture or construct this pipe. So it's given that the thickness of the lead is 2 mm. So metal thickness of, you can say, the lead, because this pipe is made of lead metal, is given to you as 2 mm, right? Is 2 mm, that is millimeter. So first of all convert it into centimeter. So the thickness, that means this thickness is given to you, this one, right? This part which I am just, which I have shaded into different color with a red color, this is the thickness of this pipe, and this thickness across all over across the cross section is 2 mm, right? So basically it's, when you convert it into centimeter, right, when you convert into centimeter, you need to divide it by 2, right? So it will be 0.1. Sorry, divided by 2. Yeah, it will be 0. Divided by 10. So it will be 0.2, because 2 mm divided by 10 is equal to 0.2 centimeter, because milli is less than centi, so that's why divide by 10. If you remember, milli, centi, deciliter, deca, hecto, kiloliter, right? So here milli, centi, decimeter, deca, hecto, kilometer. So it will be 0.2 centimeter, which is calculated, right? Now what we need to do, we need to find the weight of the lead pipe. It's given that we need to find the weight of this pipe. Weight of this pipe need to be calculated when it's given that 1 cubic centimeter of lead weighs 11 gram. 1 centimeter cube of lead weighs how much? 11 gram, right? Now what we will do, we will find how much metal is used to manufacture this pipe. Since you can see this is a hollow pipe, right? So this metal is only this red portion which is used across. So just assume the outer part, okay, it is having the radius of capital R, right? And if this thickness is 0.2 centimeter, right, 0.2 centimeter, then what you will do, if this is 0.2 centimeter, that means I want to say, if this thickness is 0.2 centimeter, then there will be some internal radius, small r, right, after reducing this 0.2 centimeter, okay, because initially it was till this end, it was capital R, that is external radius, right? So if R is external radius, then the internal radius will be how much? The external radius is 1.2 centimeter. So just put up this 1.2, or you can simply write capital R minus the thickness of this metal pipe, that is 0.2 centimeter, minus 0.2. This will give you the value of a small r, isn't it? This is a small r, right? Now put up the value of r as 1.2. So it will be 1.2 minus 0.2. So this will give you the value, this will give you the value of a small r as 1 centimeter, isn't it? Now we have almost solved this question. You know how? Because this is a pipe and into the shape of a cylinder, right? So the volume of a cylinder is the content of the material which is used to manufacture this pipe. But this is a hollow pipe, mind it. If you calculate the volume of this entire cylindrical pipe with capital R, that will give you the full volume if it would have been a solid cylinder. But when we subtract the cylinder which is inside this pipe, that means which is made up of air, right? With a, and that cylinder which will be made up of air will be having a radius of a small r, right? So that's why when you, so just that's why we will be able to calculate the metal used in manufacturing this pipe, the red part. It will be continued till the bottom, right? Now metal or lead used, metal used for pipe, right? That will be equal to pi capital R square h minus pi small r square h, right? So that will be equal to volume of the cylinder with capital R, that is your external radius, r square into h, because here you can see 3.5 mm. This is the value of h, this is the value of h, and this is common for both the external radius cylinder and internal radius cylinder, and this is vacant. So this is vacant. So do you know the vacant portion is also a cylinder of air which is of a small r, and that need to be subtracted from the bigger one, then only we'll get the metal part, right? So that's why what we did, pi r square h, volume of the external cylinder, minus the cylinder which is present inside, that is of air, that means that need to be subtracted. So that will be equal to pi small r square h, isn't it? Now this will give you the metal portion only, right? Now just put up the values and you just solve it to get the volume of the metal used. Thereafter we will multiply it with, to get the weight, by simply for 1 centimeter cube putting 11 gram, right? So pi r square h will be, pi and h will be taking common, and inside the bracket we have r square and this small r square. Mind it, this is for internal radius which is of air, and this is external radius, right, which content all the air plus metal. So this will give you, when you solve it, pi is 22 by 7 and height is given to you as 3.5 mm, 3.5 meter. Since all the dimensions are in centimeter, so 3.5 meter is converted into centimeter by multiplying it with 100, right? Multiplied by r square. What is capital R? Capital R was 1.2, so it will be 1.2 square minus small r square. Small r is 1, so this will be 1 square, right? So when you solve it, this will give you the volume. So let me write it with different color, 1 square, because this is for internal radius. So this will give you, just replace the decimal, 22 by 7 into 35 by 10 into 100 into 1.2 square will be 1.44 minus 1. So this will give you 0.44. So it will be 44 by 100, right? And this 100 and this 100 will be cancelled out, and this 7 and this 35 will be cancelled out in 5 times, right? So this will be simple calculation. 22 into 5 will be equal to 110 into 44 by 10. Again you can see this 0 and this 0, all this volume is in centimeter cube, right? So 440 in 10 times plus 44, so 484 centimeter cube is the volume of the metal is calculated, which is used in manufacturing this pipe, right? Which is manufacturing this pipe. This is the volume of metal used in manufacturing pipe, right? Now if this is the volume of the metal used in manufacturing the pipe, and it's given that the 1 centimeter cube of lead weighs 11 gram, right? And this much of centimeter cube of metal is used, so that's why what we will do, just multiply per gram with 11, so the weight will be equal to 484, right, multiplied with 11, right, because this is the 11 gram. So this much gram of metal will be used, this much gram of metal will be used, that is which is used in manufacturing this pipe. 484 into 484 into 11 gram. So when you solve it, let me solve it somewhere. 484 into 11, this will give you 4840 times plus 484, so this will be 53824. So 5324 gram of lead is used in manufacturing the pipe. So basically when you divide it by 1000, then we get kg. So this will be equal to 5.324 kg of lead is used in making this pipe, right? And this is your answer, 5.324 kg of lead, right? And this lead is used in making this pipe. So 5.324 kg. And in this way we have solved this question, students. I hope you like the solution. What we did, we calculated the external radius as given. So because diameter is given to you, we calculated the external radius with capital R. After that, the metal thickness was given to you, this shaded portion, that was 2 mm, converted into centimeter to make all units in same, so it will be 0.2 centimeter, so that is deducted from capital R to get a small r, the internal radius. So we calculated the volume of the cylinder with external radius and volume of the cylinder with internal radius, and subtracted that and just did simple calculations to get 484 centimeter cube of the metal used, that is the volume of the metal used in manufacturing the pipe. And it's given that per centimeter cube the weight of lead metal is 11 gram, so that's why we multiplied 484 with 11 to get 5324 gram of lead is used in making the pipe. And when we converted into 5324 gram into kg divided by 1000 to get 5.324 kg. So this much of lead metal is used in making this pipe which is shown to you, okay, this pipe. And this is our answer, right? If you find it useful, you can like it and subscribe, and also drop me a message how you find. If for any improvements you can suggest, I will come up with the same suggestions. Okay, don't hesitate to write me. Okay, I always welcome you and welcome your suggestions. Okay, thank you so much for watching, students. Keep on learning and keep on your efforts, and definitely you will succeed one day. Thank you so much. Take care. Bye bye.